All right, so we're going to go ahead and move on in Unit 3 with the quadratic formula. And a lot of you may have already seen the quadratic formula at some point in your math career. A couple of things I want to point out, and then I'll just do a few examples. One is that this can only be used on quadratic equations, meaning things that can be written like this, okay? It's okay not to have a b term. It's okay not to have a c term. But you have to have an x squared term, and you can't have anything higher than an x squared. So if you're dealing with an equation that has like an x cubed, x to the fourth, x to the fifth, this is not something you can use. This is specifically for quadratic equations, hence the name quadratic formula, okay? So once we have our equation written in standard form like this, notice this is our a, it's our leading coefficient, our b is our x term coefficient, and our c is our constant term. So this a, b, and c without the x without the variable, this a, b, and c is what we're using to plug into our quadratic formula. Now, this will be on your formula sheet for the midterm and the final, but it will not be on you will not be able to take a formula sheet or a note card into your Unit 3 exam. So this is something that I do expect you to know, right, to memorize, okay? All right. The other thing that you need to know is when you are working out these problems to ensure that you're working them out using the quadratic formula, sometimes in your Knewton assignments, the choices for the multiple choice questions may not be the complete answer, okay? It may not be like x equals 2 or x equals 1. It may be some part of the process of working through the quadratic formula, okay? So make sure when you're working these problems in your homework, you're showing each step on a piece of paper, and that way when you get to the correct step where the choices came from, you'll easily be able to identify which one's the correct choice, okay? Now, some of them will have you work it all the way to the end where you enter your actual answer, but just to ensure that you are using the quadratic formula, it may give you answer choices that come from, you know, a step within doing the quadratic formula. Okay, so let's look at some examples. I'm going to go ahead and move my paper up so I can leave this up at the top. So I first need to identify what A, B, and C are. And I don't do that unless this is written in standard form, which this one is. Everything's on one side in descending order equal to 0. So that means that 8 is my A, negative 26 is my B, and positive 15 is my C. Okay, the signs go with the number, but the x's do not, okay, when we plug them in. So quadratic formula says that x is equal to negative b, or the opposite of b. So if my b is negative 26, I'm going to do the opposite of negative 26, plus or minus the square root of, here, b squared. So again, my b is negative 26 squared. Then we're going to do minus 4ac. So minus 4 times my a, which is 8, times my c, which is 15. And then it's all over 2a. So 2 times my a, which is 8. Okay, so now that we have everything plugged in, now it's just a matter of simplifying. Okay, so let's go ahead and simplify. At the beginning, our double negatives here become positive. So I get positive 26 plus or minus the square root of 26, or sorry, negative 26 squared gives me 676. Okay, when I multiply these next three terms together, I have a negative times a positive times a positive. So I should end up with a negative. And when I multiply 4, 8, and 15, I get 480. Okay. All over on the bottom, 2 times 8 gives me 16. Okay. So I'm going to keep simplifying. So I have 26 plus or minus the square root of 676 minus 480 gives me 196 all over 16. Okay. And then 196 is actually a perfect square, right? The square root of 196 would be 14. So I'm going to continue simplifying. So x is equal to 26 plus or minus 14 all over 16. And then I want to go ahead and work out these two answers on top. Because these are like terms, I can go ahead and simplify. So 26 plus 14 gives me 40 over 16. And then my other answer is going to be 26 minus 14, which gives me 12 over 16. Okay, and then I just want to make sure that my two answers are completely simplified, meaning they're reduced. Okay, don't give decimal answers on this homework. Just go ahead and leave it in fraction form, but reduce it as far as it will go. Okay, notice on top and bottom, these are both reducible by 8, which will leave me with 5/2. And then 12 and 16 are both reducible by 4, which leaves me with 3/4. Okay, so that's my answer. X equals 5/2 or 3/4. Okay, so easy enough, right? Identify A, B, and C, and then just plug them into our formula. Let's look at the next one. And I'm going to go ahead and leave my screen as it is, just so that I can see the quadratic formula at the top. And once we get it plugged in, I'll move my paper up, okay? So if I look at this one, notice there's no number written in front of my x squared. So if there's no number there, it's an implied 1. So that's going to be my A. My B is the coefficient on my x term, which is -4. And then my C is supposed to be right here. And right now it's on this side. So notice I can't identify C until this is written in standard form. So I want to go ahead and just rewrite this as x squared plus 4x, and then I want to move that 5 over so that this is equal to 0. So that's going to make it a +5 equals 0. Okay, so make sure you don't identify A, B, and C until the whole thing is written in standard form. Otherwise, you might get some signs wrong, which will cause your answer to be wrong. Okay, so again, my leading coefficient is a 1. That's my A. My B is -4, and now my C I can go ahead and identify as +5. So I'm going to take those three numbers and plug them into my quadratic formula here, which says x is equal to the opposite of my b. So my b is -4, so I'm doing the opposite of -4, plus or minus the square root of b squared. So my b is -4 squared, and then we do minus 4ac. So -4 times my a, which is 1, times my c, which is 5, all over 2 times a. So 2 times my a, which is 1. Okay, so now that I have everything filled in, now I just need to go ahead and simplify this. So starting at the beginning, my double negatives become positive, plus or minus the square root. 4 squared gives me 16. When I multiply these next three numbers together, notice I have a negative, a positive, and a positive. So that's going to end up negative. And 4 times 1 times 5 gives me 20. All over 2 times my 1, which is just 2. Okay, so I'm going to go ahead and simplify what's underneath my radical here. So I have 4 plus or minus the square root of 16 minus 20 leaves me with a -4 all over 2. Okay, now there's two things I can simplify right here. One, I see that I have a negative, and remember we talked about when we discussed complex numbers, right, that a negative under a square root comes out as an imaginary unit I. Okay, so once I bring out that I, I'll be left with a positive square root of 4, which I can then simplify to just 2. Okay, so I'm going to do those in the same step. So I have x is equal to the 4 that was out there plus or minus the square root of 4, which we know to be 2, and the I that we brought out that came from the negative, all over 2. Okay. Now remember with complex solutions, we always want to write our solutions as a plus bi, right? We always want to write it as our regular number plus our I term. Okay. So I'm going to go ahead and you can either separate this into 4 over 2 and 2i over 2, or you can factor out a 2. Either way, it doesn't matter, but we need to reduce this 2 away. So I'm going to go ahead and rewrite this as 4 over 2 plus or minus 2i over 2. And then each of these will reduce, right? So 4 over 2 just becomes 2, plus or minus, here my 2's reduce, and I'm left with just I. So 2 plus or minus I. Now, in Newton, I'm not sure that they allow you to use this plus or minus symbol. So when you enter an answer like this, or if you're selecting the correct answer, you would have 2 plus I and also 2 minus I as your solutions. Okay, on an exam or on worksheets, I'm totally fine with using the plus or minus symbol, but for Newton, you might have to enter them separately. Okay, all right, let me look at one more and then I will give y'all a couple to try. So I don't have the quadratic formula written on this page, so I'm going to go ahead and write it up here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so again, that is a formula that you're going to need to know. And then we're going to go ahead and identify what A, B, and C are. Now notice this is not in standard form. So I don't want to identify A, B, and C until I have it written all on one side in descending order. So I'm going to move this 4x over here to this side, okay, which is going to make it a negative 4x. So that will give me negative 3x squared minus 4x plus 2 equals 0. So not only did I move my 4x to the other side by subtracting, but I made sure I put it in the correct spot, right? My x squared goes first, then my x, then my constant term. So this means that my a is negative 3, my b is negative 4, and my c is 2. So once I know what all my numbers are, now all I have to do is plug them into my formula. Okay, so I have x is equal to negative b. So my b is negative 4, so I'm going to do the opposite of negative 4, plus or minus the square root of b squared. So we're going to do negative 4 squared minus 4ac. So minus 4 times my a, which is negative 3, times my c, which is 2, all over 2 times my a, which is negative 3. Okay, so let's go ahead and simplify. So at the beginning, my double negatives become positive. So I have 4 plus or minus the square root. Negative 4 squared gives me positive 16. And then when I multiply these three numbers together, I have a negative, and a positive. So two negatives is going to make a positive times another positive is going to be positive. And 4 times 3 times 2 gives me 24. All over 2 times negative 3, which is negative 6. Okay, so I want to go ahead and combine what's underneath my radical here. So I end up with 4 plus or minus the square root of 40 all over negative 6. Now 40 is not a perfect square, unfortunately. So if 40 is not a perfect square, I want to try to simplify this radical a little bit, okay? And remember, we can simplify radicals by taking out perfect squares out from underneath them, right? Or looking for two copies of a number underneath it. So I'm going to come down here below and just look at 40 and see if I can prime factor it a little bit, okay? So 2 goes into 40 20 times, right? And then I can break 20 down. 2 goes into 20 10 times. And I can break 10 down because 2 goes into 10 5 times. And then 5 is prime. So that's as far as I can go. But notice I do have two copies of a number. I have two copies of a 2, right? 2 times 2 is 4. If I take the square root of 4, it gives me 2. So anytime I see two copies of a number, I know that that number comes out. So I'm going to bring out a 2. And notice I'm still going to have a 2 and a 5 left over underneath the radical. So if I multiply those together, it's like I'm going to be left with a 10 underneath my radical. So I'm going to go ahead and come down here. So I have the 4 that was out front, plus or minus, remember I brought out a 2. Underneath my radical, I'm still left with a 2 and a 5, so I multiply those together, which gives me a 10. All over, on the bottom here, I had a negative 6. Okay. Now, I'm done in terms of kind of simplifying underneath my radical and reducing my radical, but I still have to check to see if there's anything I can reduce now that I have my radical simplified, okay? And notice every single term here is reducible by 2. So what I want to do is I want to go ahead and factor out that 2 so that I can reduce it with a negative 6 on the bottom. So I'm going to go ahead and factor out a 2. When I take 2 out of 4, I'm left with 2 plus or minus. When I divide a 2 off here, I'll just be left with the square root of 10 all over negative 6, right? And now that I've taken out that 2, I can reduce here. So 2 goes into 2 one time, 2 goes into negative 6, negative 3 times. So I'll be left with 2 plus or minus the square root of 10 all over negative 3. And that is my final answer. Okay. I can't go any further because 10 is stuck under the radical and 2 does not have a radical, so those can't be combined. And I can't reduce anything because I would have to be able to reduce by all 3 terms, and they don't have anything else in common. Okay. All right, so there are 2 for you to try at the bottom of this page. I'll go ahead and give you some time. Pause the video, work them out, and when you feel like you're ready to check yourself, play the video and we'll see how you did. Okay. All right, so number 1, our A is -6, our B is 2, and our C is 1. So when we plug in all of our numbers, we should get down to where we have -2 plus or minus the square root of 28 all over -12. 28 is not a perfect square, but we can try to prime factor it to see if we have any double copies that can come out of that, right? So 28 is 2 times 14. 14 is 2 times 7. I do have 2 copies of a 2, which means I can bring a 2 out, and I'll be left with that 7 underneath the radical. So I'm just going to rewrite this as -2 plus or minus the 2 that I brought out, square root of the 7 I had left over, all over -12. And then here again, these are all divisible by 2. So in the example that I showed factoring out the 2 and then reducing it with the 12. You can do it like that, or you can just know to reduce all 3 terms by that number. Now you can only reduce if you reduce all 3 terms by that number, okay? So when I reduce -2 by 2, I'm left with -1. When I reduce 2 square root of 7 by 2, I just have the square root of 7. And on bottom, when I reduce -12 by 2, I'm left with -6. So we're going to leave it just like this, okay? Notice I am not getting decimal answers for these, okay? I am leaving them in reduced radical form, which is how you will do it on worksheets and also on the exam, okay? All right, and then on the second one, same idea. We need to get it into standard form first by moving that 4 back over to the left-hand side, which makes it positive. So our A is 4, our B is -5, and our C is 4. So I plug everything in, simplify, and I'm left with 5 plus or minus the square root of 39 over 8. And notice if I try to simplify the square root of 39, 39 is just 3 times 13. Both those numbers are prime, so I can't break it down anymore. And because I don't have 2 copies of a number, I can't bring anything out, okay? So I just leave it like this, and that's my final answer. All right, so that is the end of the quadratic formula section. So you should now be able to complete the quadratic formula assignment in Knewton. If you have any questions or issues, please let me know. Otherwise, get to it.